Hello everyone, I hope that our studies are going fairly well. I just want us to go through this learning unit once again. Remember, so far we did stem and leaf plot, so make sure that you master that. So for now, I want us to focus on the pie charts. Pie charts are very, very simple. Normally in the exam or a test, sometimes they give you the pie chart and then thereafter they ask you question based on the pie chart. So for now, I'm just going to show you how to plot a pie chart. Remember, pie chart is another technique that we can use to present workplace data. Firstly, let's see here, we've got the cars here. We've got cars and we've got sales. So here I'm talking about the sales units. So I'm just going to make sure that I plot the number of cars and then at the same time show the sales units for those cars. So as you can see here, guys, I've got the BMW. I'm just trying to find I've got BMW here, and then I've got Audi, I've got Toyota, I've got Opel, and I've got Toyota. So according to this information, I've got, can you see, for BMW, I sold 50, for Audi, I sold 70, Toyota, I sold 45, Opel, I sold 25, and all in all, they are 190. So this information can be plotted on a graph, but for now, I'm just going to show you how to plot it on the pie chart. Normally with the pie chart, we normally show the information in the form of a percentage. So I will make sure that I express sales units in the form of a percentage. So you know that if I have got 50 BMWs, it means I've got 50 BMWs out of how many cars? Out of 190 cars. So I can say 50 divided by 90 so that I can know how much is the percentage for this BMW. So for example, if you can see here, if I say 50 divided by 190, I multiply it by 100 so that I can have a percentage. How much do I get? I get 26%. Same applies to Audi. I'm going to say 70 divided by 190, multiply by 100, and I will get 37%. And the same applies to Toyota. I've got 45 divided by 190 times 100, and I get what? 24%. And then for Opel, I've got 25 over 190, and I multiply them by 100. I get 13%. So when you add all these percentages, they must add up to what? To 100%. Again, even if you don't want to find, because here for me to find this 100%, I said 26% plus 37% plus 24% plus 13%. You can also say 190 divided by 190 multiplied by 100. So again, this will help us to plot the information on what? On the pie chart. So the pie chart will look as follows. Can you see now? Can you see now? Here, each and every percentage here is represented by a section of what? Of that pie chart. It's like a pie. So can you see 26%? Is 26%, and we've got 37%, we've got 24%, we've got 13%. And again, can you see it's easier for me to know that this percentage, 26%, belongs to what? BMW. You can see here the color of the BMW here. So this, in a nutshell, how to present the information on the pie chart. Please, for more information, go and learn from the book, and you will get more information there. Okay. Let's continue to the line graph. Again, line graph, guys, is very much important. It's easier to plot. Again, you need to have the points that you're going to plot on that particular a graph. So we need to understand that we need to have the number of units, for example, here, and the number of what? The cost for those units. So a line graph has got two axes. We've got the y-axis and the x-axis. So you must have where we plot our units and where we plot our costs. So if you can check here, we've got, for me to have 1 unit, it's going to cost me how much? 5 rand. 2 units, 10 rand. 3 units, 40 rand. 4 units, 50 rand. So I just came up with this data. So let's see how can we plot this information on the line graph. Can you see? So this shows that, for example, if I've got 1 unit here, can you see now? So it means 1 unit is gonna cost me how much? 5 rand. So this is the, can you see, this is the y-axis. So here we put the cost and here we put the number of units. So if I say I only have or produce 1, can you see how much is the cost? Is 5. So 5 is somewhere here between 10 and 0. So if I've got 2, can you see here? It means I have a cost of 10. As you can see, it is correlated to this table. So easier to understand. Please study the line graph so that if they ask you questions based on this graph, you are able to answer. So if you don't know how to read the graph, it means you will struggle. So again, please go to the book and make sure that you understand. For example, 4 units, it cost me how much? 50. Can you see now? So again, we need to know how to ask you questions based on this. Okay. The next graph is called bar graph or bar graphs. And again, I'm just going to use the cars in order for me to present this information to you. Bar graph is where we have to use columns where we have to determine whether that column represents the highest or the minimum. Okay, it's like we use the rectangles, which will show us the information about particular means of distribution. So at the end of the day, I'm still going to use this. Can you see I've got for BMW, I've got sales for 50, and as you can see, this is the information that I used before. So we can use this information in order for us to compile a bar graph. A bar graph looks like this. Can you see now? This is it deals with the quantitative data. In other words, it deals with quantities. For example, here we've got BMW. How many BMWs did we sell? We sold 50. Can you see here? BMW, we have got 50 here. Can you see? For Audi, as you can see here, 70. Can you see now? So reading this information, you can see how many units did we sell? Which one has got the most units? Can you see? So at the end of the day, we need to know how to plot. As you can see, we use columns, for example, like this, and then again we use like bars in a way. So this bar represent this BMW, and it shows that I sold how many? 50 BMWs. So again, you must to read this data. Remember, these bars must not be connected. They must not touch each other here. Can you see? And then the space in between, can you see, must be of the same length or the same width. So at the end of the day, this will be called what? Bar graphs. Like I said, bar graphs don't touch each other except if the data is continuous. For example, the data that is continuous, obviously, you'll see by the time when we deal with the categorical data, where we have to, can you see, put specific units within a particular range, you'll see that those bars will touch each other. We normally call them histograms. At the same width of data, and then same distance between the bars, labeled axis. Okay, when we say labeled axis, in other words, you need to make sure that you label this. These are marks at the end of the day. And again, don't forget to have what? The heading here. So you must always give us more information about the graph. Again, for more information, guys, please and go and look, just go through your book. They explained in detail. So this video just tries to summarize what is important. And now we've got histograms. Histograms are similar to bar graphs, but this one uses what we call the categorical data. We don't use quantitative data. In other words, for example, we are trying to plot the frequency according to a specific range or a specific interval. You will see, for example, here, I just put this information here, just only the graph. As you can see, I've got this histogram shows age categories for number of people. So this axis uses what? Number of people, and this one has got what? Age. Can you see between the age of 1 and 5? How many people are there? 5 people. Can you see now? Between the age of 5 and 9, how many people do I have? Can you see now? So it shows you can read the graph at the end of the day. But you must know that the histogram, the bars are touching each other, even though as you can see here, maybe you think like this is not touching is because of maybe the way it has been laid out on this PowerPoint, but this must touch each other. In a way, they are touching each other. There must not be a space in between. So this graph represents histograms. Okay, the difference between histograms and bar graphs, the bar graphs, remember, they don't touch each other unless if they're continuous, but histograms touch each other. So make sure that you know the difference between the two. Can you see? That's why we call this a categorical data. Why? Because it's like between the range between a particular interval 1 to 5, 5 to 9, 9 to 13. Can you see here? These are the number of people who fall within these categories at the end of the day. Again, remember, bars touch each other, and again we need to label this axis. We call this x-axis and we call this y-axis. We've got what we call the frequency distribution. To be honest with you, the frequency distribution is just the same as when we were doing the categorical data, where we say there are 25 people within the age of, let's say, 60 and 70. Can you see? That will be the frequency distribution. Let me show you something. This represents the number of observations within an interval. An interval is like a range from 1 to 5, from 5 to 10. Okay, the data is categorized in a frequency distribution. Like I said, so when you say from 1 to 5, it means you are categorizing those observations. Okay, for example, here, as you can see here, I just came up with this data between between the cars. And this is the cost of buying the cars. So the cars which cost between 100 and 100,000 and 150,000 are 5 cars. Can you see? Those which are between 150,000 and 200,000, they are 8 cars. Those which are between 200,000 and 250,000, 6 cars. Can you see? So this is called the frequency distribution. So it's the frequency. This is the number of observations. So all in all, how many observations do I have? 20 observations. Can you see now? So this is categorical data, and this one is called the frequency. Sometimes we can talk about what we call the cumulative frequency. The cumulative frequency, like you can see, adds separate frequencies together. You will see by the time when I show you the example, it illustrates total number of times that the value above or below a certain amount occurs. For example, as you can see here, this is how we deal with the cumulative. We say those numbers which are more than 30 but are equal to or less than 40. In other words, they are between 45 and 30, but even 45 is included. Can you see now? So according to this, the number of frequency we say they are 5, 8, 6, and 1. All in all is how much? 20. But how do I calculate the cumulative frequency? Remember, to cumulate is like something is adding up. As you can see, this is the first observation. Obviously, I said only 5. But for me to find the second observation, I just say 5 plus 8, I get what? 13. 13 plus 6, I get 19. 19 plus 1, I get what? 20. So this is called cumulative frequency. Can you see? You have to take the normal frequency and you convert to a cumulative frequency by saying, for example, here obviously because it's the first one, you just have to say 5 here. Now you say 5 plus 8, you get 13. 13 plus 6, you get 19. 19 plus 1, you get 20. Okay. So this information can be plotted on a graph and it can give you something like a line graph. The minute you plot it on the graph is when that we talk about the OGIFs. Okay. The OGIFs, it presents cumulative value that is less or equals to or greater or equals to. Okay, so it is important for us to be able to understand what is an OGIF. So for more information, please go to the book. So in a nutshell, as I said, when we talk about the OGIFs, is when we plot this on the graph. You will see this will give us like something like a line graph. And again, this can be, for example, if you can see here, this is 5, 13, 19, 20. So in other words, the slope for this particular graph will go up. Like for example, if you plot it, it's going to go like that, going up. But sometimes you can find that we start with 20 up there and then we end up with 5. So the slope will start downwards. Can you see now? We've got the downward slope and the upward slope. But for more information, please go and check that information in the book. Okay, so please make sure that you understand how to deal with that information. Okay, I hope you can, again, as you can see, this is the information that you can use. For example, we go and plot. That's why this looks the same. I'm going to go and plot this information, not this information. This is for the frequency. I'm talking about the cumulative one. Okay, so please make sure that you go and read more from your book. Thank you very much. And then at a later stage, we'll take questions so that we can know how to answer those questions. But for now, please check your book. You have the answers in your book. Make sure that you know how to deal with them. Thank you very much, guys. And then I hope all is well so far. Thank you, thank you, thank you, thank you, thank you very much. And then please, if you've got any question, you know where to find me. Thank you very much.